So as clearly stated in the title of the worksheet, today's lesson has something to do about power. And power is defined basically, according to science, is the flow of energy. So energy that is flowing. So let's say if you have 5,000 joules that is flowing from one point to another. So in order to illustrate this, let's take a look at this scenario and let me read it. Suppose that you and a friend, so both of you, are given a task, we're given a task to move 500 newtons piles of potting soil. So soil used for the garden, and the garden is about 100 meters away. So you have to move it 100 meters away. And it's very impossible for us to lift 500 newtons pile, and instead we are going to drag it. So you accomplish the task in 10 minutes. So here's the scenario. Let's say you took about 10 minutes while your friend took 30 minutes. So your friend took 30 minutes, but you did the same amount of work. Why did you do the same amount of work? Because the distance and the force that you apply is going to be the same. Let's make the assumption that you pulled, both of you pulled, use a different color pen so you can see. You apply the force that is equivalent to 475 newtons. 475 newtons. So 475 newtons applied at a distance of 100 meters. Again, force is 475 newtons, while the distance d is equivalent to 100 meters. Now, if both of you apply the same amount of force and same amount of distance, it is empirical to say that both of you did the same amount of work. And the definition of work is simply work is equivalent to force dot multiplying the distance. Plugging the information, so both of you did work that is equivalent to 475 newtons multiplied by a distance of 100 meters. So therefore, it is 475 times 100, so that's 47500, or 47,500, and the unit is joules. So unit is joules. So both of you did the same amount of work. Did the same amount of work, and that is 47,500 joules. Now the question is, how is it different in terms of power? How is it different in terms of power? So that's when time kicks in. So here is the definition of power, which will give us the letter P, where it represents power, is simply equivalent to either energy divided by your time period. So this will be your definition. Well, energy E can either be kinetic energy, which is 1/2 mv squared, or potential energy, and that is mass times g times your height. Or if you're talking about work, because power is also equivalent to work over time. So it's either energy or work, because energy is the ability to do work, while work is your force multiplied by the distance along the same axis. So work, W, is just like what we used here on the upper portion, and that is your force times or dot multiplication of distance. Distance. Now let's apply, or let's figure out the different symbols. Okay, so we are familiar with the symbols. Nomenclature, or the symbols. A symbol for power is P. work is W, or if we're talking about energy, so there's two types of energy that you may want to use, but the general symbol for energy is E. If we're talking about kinetic energy, so therefore that's Ke, and if we're talking about potential energy, then that's Pe. If the energy is in other form, for example, not mechanical energy, such as solar energy, thermal energy, therefore just use the letter E um, as your symbol. Now, time, we always use letter T or lowercase t as our time. Or in some cases, you might see delta T as the symbol for time. So it's either one of them is allowed. The units for power, I know you're familiar with time, so the unit for time that we're going to use is seconds. So it's supposed to be seconds. Or S, so that's a symbol for seconds. Work is in joule or joules, which is letter J. And then power, now we're going to have a new unit, which is also known as watts. It's named after the scientist James Watts. And the symbol is lowercase w. Lowercase w is your unit. So all we have to do is divide the energy or work by time t. And time t is in terms of seconds. So in this example, let's figure out how many seconds and how many is the total time that was consumed by each of the following person. So you and your friend. So for example, took you 10 minutes. 10 minutes. So let's write it down. 10 minutes. How many seconds is 10 minutes? So 10 minutes time if there are 60 seconds in 1 minute, 60s is to 1m or 1 minute, then it took you, so it took you 60 times 10 or 10 times 60 will give you 600 seconds. So that will be the amount of time that it took you to move this piles of garden soil from the source to the garden, while your friend took 30 minutes. So if your friend took 30 minutes, which is 30 minutes, and there are 60 seconds in 1 minute. Now we can say, using the calculator, 30 times 60 will give us 180. So 30 times 60, so that will give us 1800 seconds. So 1800 seconds. So that's the total time your friend took to finish the job, to finish the work, while you only took about 10 minutes, which is 600 seconds to finish. Now let's analyze who among the two of you did possess more power or a faster flow of energy. So basically power is how fast energy is flowing. So let's say this is you in your condition compared to your friend. So let's use the space over here. So your power, P, is the amount of work. Since we're talking about work, not energy, so that is work divided by time. And if you did the same amount of work, which is 47,500 joules, divided by time of 600 seconds, so the total power or the flow of energy that you experience as you were doing the job is equivalent to divided by 600. So that is 79.167, and the unit is in W or watts. Now let's simplify the answer for your friend. Same amount of work done, and that is 47,500 joules divided by 1,800 seconds. Therefore, the amount of energy flowing from your friend, or also known as power, is 47,500 divided by 1,800. So it is only 26.39 watts or W. So this means that the shorter time needed to commit or to perform the same amount of work or energy is basically telling us that you are conducting or flowing more energy than your friend, or you have more power since you did the work in lesser amount of time. In the next video, you will be looking at additional examples.